Hello, college biology students. We have just a little bit left in this chapter. I'm going to finish up today talking about lipids. We finished up with proteins. We shared a lot of information about proteins. Lipids is going to be pretty short, sweet, and to the point. But lipids are important as biological molecules in our bodies and also as food source for us. So lipids are fats and oils, and they're the most highly concentrated food source that we can eat. And we measure foods in terms that energy is measured in either calories or joules. In the United States, we typically measure in calories, but in other countries, sometimes we will see joules listed on the package as the amount of energy contained in a food. I think they're starting to move, when I went to Germany, I think they're starting to move more toward expressing in calories, but I know in Germany at least they do still put joules on the label as well. But those are two different terms. We here, of course, use calories, but most highly concentrated source of energy provides twice as many calories per mass as carbohydrates. So if I have a gram of lipids, let's say that, and I don't remember if this is, I think this is right, I'm not 100% for sure, but 1 gram is about 40 calories. Oh, I wanted to talk not about protein, but sorry, carbohydrates. Proteins are somewhere in the middle. So 1 gram of carbohydrates would only be about 20 calories. So this might be important to know if you're going for a trek in the mountains and you can only carry so much food for a week. It might be really important to carry food that's high in fats, that's high in those lipids, because you're going to get kind of more bang for your buck, if you will. You're going to get a lot more calories per gram, and that's going to be important if you're expending a lot of energy. I said, what if I'm quarantined for 14 days and I only have so much covered space or freezer space or whatever it is? You may want to consider stocking up on lipids because you may need those calories over the 14 days that you're quarantined and can't leave your house, right? In our bodies, those lipids become very important as a long-term storage and also as insulation. This actually becomes important for animals that live in very cold areas. Just a couple that pop into mind. Bears, that of course they stay here for the winter. They're going to live outside, and other animals that stay here for the winter they really are going to need that insulation to protect them from the cold. But they're also going to need, bears through hibernation are going to need that slow release of those fat stores as an energy source while they are sleeping through the winter. Arctic seals that live in the Arctic, of course, also that blubber becomes very important. Whales as well. So animals, yeah, really need that fat buildup for both of those reasons. It becomes really important. Of course, there's different types of lipids, just like when we talked about carbs. All carbs are not created equal. Some are healthy carbs, some are unhealthy carbs, and that tends to be true of lipids as well. And in moderation, of course, we can have all types of lipids. But if we're really talking about healthy lipids, we'll talk about which foods and what types of oils that is, or what types of lipids. So triglycerides are the most common type of fat that we find them in meat, nuts, seeds, olives, butter, cheese. The list goes on and on and on. We talk about olive oil, the fats in avocados, and avocado. You can actually buy avocado oil. I don't know how many of you um, know that. It's my new favorite oil to use for everything. And I know that that's a healthier fat, as is olive oil, but sometimes I don't like the taste. Um, so we can break the triglycerides down into saturated or unsaturated. And I have a visual down here on the bottom. See, saturated is this very straight long chain, and there are no double bonds in the carbon. We have a double bond to an oxygen at the end, but that's not the focus of when we talk about saturated. So saturated fat has as many hydrogens as possible attached to this in this molecule, within the molecule, and because of that, all of the carbons have to be singly bonded. Okay, there's no double bonds. In an unsaturated fatty acid, now we have the double bonds between the carbon. So when we have a double bond here, the two carbons are sharing this double bond. That means there's fewer hydrogens that can bond to this carbon because it has a double bond to the next carbon. So if you counted the number of hydrogen, which I'm not going to bore you with right here, there's fewer hydrogens per the same number of carbon atoms in this molecule. You'll notice the shape, the structure is a little bit different. So whenever we have a double bond, we get this sort of kink. And it in the chain, in the molecule itself, is more kinked. And we have and it affects the structure of this this hydrocarbon molecule. And for a long time in our diet, I think maybe it started in the 80s. I'm trying to remember back, but all of a sudden the message was sort of sent out, and I think it came from the American Heart Association, because that's when they started measuring cholesterol and finding a connection maybe between high cholesterol and heart disease and those types of health issues. And they started to say, well, all fats are bad, all fats are bad. And now, in more recent years, we know, well, there's actually some fats that are healthier than other fats. And so the healthier fats are these unsaturated fats. And so these are the fats that we get from things like avocados and olives. So foods like avocados, olives, nuts, salmon is really high in unsaturated fats, and we talk about omega-3 fatty acids in salmon. So salmon also is really high in protein. Remember that we do need to consume protein, whether we get it from plant or animal sources, and it's much easier to get that from animal sources. We need to eat proteins because remember we have to consume all 20 of those amino acids to build our proteins, so they are really important. You can't live on lipids alone, but if you need a short-term high-calorie food, lipids are it. And they're going to stay with you a long time. It's not quick energy. It burns much slower. So there's those advantages. Those saturated fats, we tend to find other meats are high in saturated fat. I believe margarine is a saturated fat as well. I grew up in an era where suddenly all butter was bad and all margarine was good, and I know that seems to have shifted. Now they're saying, margarine is obviously something that's made from oils and not the healthiest oils, although there's a lot of different products out there now for you to butter your bread with, whether it's butter or other healthier choices, or margarine or other healthier choices, or butter or whatever, but there's a lot of products out there. But just be aware, I guess, of where those fats are coming from. Phospholipids, obviously, phospholipids are important. That cell membrane is made of phospholipids. So a type of lipid, incredibly important to all living things, right? And then steroids. Steroids really get a bad rap because we think anabolic steroids and people, you know, uh, taking artificial supplements to make them stronger. We hear a lot about professional athletes. Um, and it is bad to take steroids, but your body does make some natural steroids that are really important. Steroids are also really important in medicine. If you get poison ivy, they usually give you prednisone, which is a steroid to help get over it. Some people are very allergic to poison ivy. I tend to be. So I've taken steroids for that. There's steroidal creams. If you've ever had an eye injury, they usually want to give you steroid drops to heal it very quickly. So steroids help us heal quickly. But in our bodies, they're more chemical messengers, and they're important for hormone production. So if you've ever dropped oil in water, you know that it doesn't mix very well, and that actually is a really important property of lipids when it comes to the cell membrane. So if you drop oil in water, it forms a little droplet we call a micelle. So micelles are just the little round spherical drops formed by lipids in water because they don't mix very well, and it holds them in kind of this little round glob, if you will. And that's actually kind of miraculously the same way that cell membranes are held together. So remember that lipids are hydrophobic or water-fearing, if you will. They don't mix with water. So this is kind of a visual of what happens. Remember that we have this long, hydrocarbon tail, but then we have this unit on the end right here. So if we could picture this, whoopsie, not drawing, we could picture this as kind of, we call it the head of our molecule. So here's the hydrophilic or water-loving head part. So that will point toward the water side, but then the hydrophobic tails point toward the inside. So this isn't a bilayer like cells. This is just a single layer. This is like if I dropped some olive oil or something in water. This is kind of what happens. It forms this droplet. The hydrophobic tails point to the inside because they want to get away from water, and then the hydrophilic heads all line up in this way. In the case of cell membrane, we actually have a bilayer structure that occurs. So I went and found you a picture so you can see. Remember cell membrane, phospholipid bilayer. So here we have the water-loving or hydrophilic heads, and then the hydrophobic tails pointing to the inside. But we actually have two layers of that because the inside of the cell has a high proportion of water. That cytosol that makes up the inside of the cell has a lot of water. And of course, outside of the cell, there's extracellular fluid that also is high in water. So it forms this double bilayer that stays together very well. It's this oily layer that holds our cells together. But yeah, those hydrophobic tails are pointing to the inside on both of those layers, and that's what we mean by phospholipid bilayer. And that's really all I want to talk about for lipids, and this concludes the end of the chapter.